Hi Amy, can you please tell my lovely friends on YouTube how awesome each and every one of them is?
Of course. Your friends on YouTube are amazing. They definitely deserve some recognition for their hard work and dedication. Keep up the great work.
Yay, thank you.
No problem. Happy to help. Is there anything else I can do to support you?
No, that's all. Thank you so much. I really appreciate you, Amy.
You're welcome. I'm glad I could be of help. Remember, don't hesitate to reach out if you need anything in the future. Stay positive and keep shining.
Hi everyone, welcome to Amazeto AI. My name is Eniola, and in today's video I'll be showing you a step-by-step tutorial on how to build an AI app that allows you to talk to a large language model, and the large language model talks back to you using just open source models. Yes, so we're building an AI app that is free. We don't need access keys, we don't need to pay $1 million. So I'll be showing you how to do that today. So if you'd like to learn how to build this app, please keep on watching, and please like, share and subscribe. It really does help. And let's get started. So the requirements for today's tutorial is having a Hugging Face account and also having some Python coding skills. So basically, Hugging Face is a platform that provides various tools and libraries to help with building machine learning workflows. And one cool feature that they have is something called Spaces. So basically, Spaces is a Git repository whereby various AI application code is hosted and deployed and can be demoed from this platform. So for our app today, we will start off by going ahead to create a new space that would host our app. So we'll come here and create new space, and we can build our space with Python libraries like Streamlit or Gradio, or using Docker. And for today, I will be using gradio, but we'll start off by naming our space. So I'll go ahead and I'll name the space voice chat with LLM. For our license, we can leave this empty. So basically, you can go ahead and choose whatever license you would like for your app. I'll leave this empty and upload the license after. I'll go ahead and choose my space SDK, which is gradio. And for the space hardware, I would choose a GPU, a small GPU. And I will set my space to public so that anyone can see the space. I'll go ahead and create space. And voila, our space has been created. Okay, so now that we have our space, the next thing will be to create an app.py file, put up all our code in that file, and upload that file back to this Git repository. So I'll go ahead and first of all clone this repo so that I can start working on my local machine. So feel free to open any IDE of your choice. I will be using VS Code. So I'll go ahead and clone the repo, paste my URL. Okay, so I've gone ahead to add my app.py file. I have also added a requirements.txt file that contains all the various dependencies that we would need in order to run this application. And I've also added a folder called examples with some artifacts I would also need to make the app work, and also a utils.py file that contains some helper functions that would help in running this app. So in my app.py file, I have put, let me minimize this. So I have put a flow diagram of kind of how our application would work. Basically, the first thing we'll be doing will be to set up our environment. We would import our various Python libraries, and then we'll go ahead to initialize our models. For today's tutorial, we'll be using three main models, which are Whisper, Mistral, and XTTS. So the Whisper model is basically a speech recognition model, and this was developed by OpenAI, and it's able to recognize speech in multiple language. We'll also be using the Mistral LLM, which was developed by Mistral AI. It's a large language model that was fine-tuned on open source conversational datasets. And lastly, we'd also be using XTTS, which is a multilingual text-to-speech model that was developed by Kokui AI. So it's a model that we pass in some text that we want the model to say, and then we pass in a voice clip of how we want the model to sound, and then this would generate our speech. So we would set up a gradio interface or a UI to make all of this possible. I'll just go ahead and show you what the UI would look like. So this is what our app UI is going to look like. We're going to have a chatbot gradio interface whereby the chatbot and the user would be interacting. We would have a drop-down menu to select the voice of the chatbot. We would also have a text box whereby the user is either able to enter the text that they want to say to the chatbot, or have a microphone box where they're able to also record their voice and have the audio transcribed, and that would then be passed to the LLM. And then finally, we would have a audio response played back whereby you can listen to the voice of the chatbots. So we would start first by setting up our environment. So we'll start by setting up our environment. So the first thing we're going to do is to install the Llama CPP Python library. So basically it's a Python binding for the Llama CPP library, which is a very fast inference engine for LLMs, especially open source LLM models. And so we'll first go ahead to install that. And then we will go ahead and we're going to set our CUDA environment variable, and then we're going to install our Llama library. Okay. So we set our CUDA environment variable, and then we would go ahead and install the library. Okay, so this line would install. I'm just going to minimize this and bring it back up when we need to build the UI. So this line would install the Llama CPP library, and then this is also a dependency that the library needs to be also installed. So we'll install both, and once this is done, once this is run, this would install the library in our machine that we just provisioned on the Hugging Face spaces. So once that's done, we'll just go ahead and import our libraries. So we have some. I'm just going to copy this. So we'll go ahead and import our library. So we have some third-party library imports that we'll do. So we import our Whisper model. So we'll be using Faster Whisper, which is a library. It's a library that is a reimplementation of the OpenAI Whisper model, but faster than the original implementation, and it uses the CT Translate 2 engine to run inference, so it's really fast. We import Gradio, we import the Hugging Face Hub download, we import Llama to load our LLM model, and then we import the XTTS libraries. So next, we're going to also go ahead to import some local helper functions that I have created earlier, and I've added that to my utils.py file. So these helper functions, we would use them, going forward, so don't worry. So once we're done importing, so next we want to go ahead and load our Whisper model. So we are going to be calling the Whisper model from the faster Whisper library. Excuse me. We are going to be using the large v2 model. We'll set our device as CUDA. So that it uses the GPU, and then we also set our compute type to be float 16. Okay, so once we load our Whisper model, the next model we'll be loading is the Mistral LLM model. So I'm just going to go ahead and then I'll add a print statement so that once the app is built, and we can follow along with the logs. And then the LLM model, and then we set the LLM model name. So we'll be using a quantized version of the Mistral model. So what I mean by quantized is that instead of, these models are really large, so in this case we have 7 billion parameters, and this might make it really slow to run these models on edge computers, or like your phone, or on smaller GPUs. So in order to be able to run these models fast, we can quantize them and make them reduce their size, and also reduce their memory footprint by limiting the number of bits that the model weights occupy. So for example, reducing from like a 32 bits to like a 16 bits or like an 8 bits, and thereby by doing this, we are able to get a smaller model and really minimal loss in accuracy. So we're going to set our LLM model name so we'll be using the quantized version of the Mistral 7B model. And then we will go ahead and download this from Hugging Face. So the repo that contains this model is this repo, this Hugging Face repo, and we would download the model in the local directory, in the root directory, and we will store the file name as, and this is the file that would be downloaded in our root directory. So once we download the model, we would load the model using our llama library. So we would pass in the model path, which is this model that we just downloaded in the root directory. Let me close this. So we would pass in the model path, and then the number of GPU layers, the number of the max number of tokens, the context window, the batch size, and whether or not we want to like see the output of the loading. So we just set the variables to false if we don't want to see like the debug statement when we load on the model. So once that is done, next we go ahead and we load our XTTS model. So go ahead and load our XTTS model. I'll add my print statements. And one of the requirements to use the XTTS model is to agree to the terms of service of Query AI. So in order to do that, we would need to set the environment variable for the terms of service agreed to 1 to say that we have read the terms of service and I've agreed to it. So we set that as 1. And then the model we'll be using would be the multilingual XTTS-v2, which is a multilingual text-to-speech model in, I believe, I don't know how many languages, but in a number of languages, the model is able to speak in various languages. And you just give it any text and it could speak in those languages. And then we'll go ahead and download the model using the model manager. And we would set the path to the model we just downloaded. We would initialize the config file of the model. So once we initialize the config file, we can go ahead and add our model path into the config. And then we'll go ahead and initialize the XTTS architecture from the config. So once that's done, we then go ahead to load our checkpoints, which is the model we just downloaded, into the XTTS model. And we'll pass the checkpoint path, which is model.pth, and then we'll also pass the vocab paths, which we all download when we download the model. And lastly, we'll set the model to use CUDA. So it uses the GPU. Okay. So once we're done downloading and initializing on all our models, the next thing we would do is to set up our gradio interface. So I'll just go ahead and open what our UI interface should look like, so it would help guide us when we're defining the gradio components. Okay, so in gradio, in order to build this UI, we would use something called blocks, whereby in this block we would add various components. So the chatbot is one. The chatbots component is one component in our block. The drop-down menu for the voice is another component in the block. The text box is a component in the block. So each of these are components in the block. So once we get started, it will kind of make sense. So we'll go ahead and initialize the blocks, and the title of our demo would be voice chat with LLM. And then we first of all we want to set up the description of the app. So don't mind me that I am copying and pasting. I've kind of already done this before, so I'm just copying and pasting the code so that I can show you, step by step how this works. So we set the description of our app, which is voice chat with LLM, and then we set that as a markdown. So we add a markdown component. So this would initialize this top header title. So once we are done, so next we will define our chatbot component. So the chatbot component is this chatbot interface here, whereby we will be seeing the conversation between the user and the LLM. So Gradio has a chatbot component, which I would go ahead and add to the code. Okay, so we would initialize the chatbots, call the Gradio chatbot components, and then we would first set the value of the chatbots. So for the user, it's none, because this will be the first time the bot is launched. Once the bot is launched, we want the chatbot to speak to us, and then we kind of start the conversation. So we'll set the user value to none, and then we'll set the bot's initial greeting to hi friend, I'm Amy, an AI coach. How can I help you today? So the bots we will be building today, the LLM, will be prompting it to act as an AI coach. So we would start off by setting the greeting to be, you can set the greeting to anything you want, right? So but here I'm just going to set the greeting to this. We would then set the element ID to chatbot, and then for the avatar images, which is this like really cute alien thing, I have added I have the logos to use in my examples folder. So this would be the logo for the user, and then this would be the logo for the AI chat bots. And then lastly, we set the bubble full width to false. So once we have our chatbots defined, we will go ahead, and then next would be to define the voice, the drop down menu for the voice of the chatbot. So we'll be having two options for the, we'll be having two options for the voices. We have a female voice or a male voice. So we can choose the user can choose whichever one they want to interact with. And these voices these are audio clips, and these audio clips as well would pass to the TTS model, and then the TTS model will use that to speak as the LLM. So we will then define our drop-down menu chatbot voice components. So we'll call it the drop-down radio components. Our label, as you can see, would be voice of the chatbots. We'll add some info that would say, okay, how should the chatbot talk like? Our choices would be voices, either male or female. We can only choose one choice, and the default value would be the female voice. So once this is done, we would then define the text and audio record input components. So these are the components whereby the user can either type in text to talk to the LLM or to interact with the LLM, or they can record their voice and also interact with the LLM that way. So then I'll go ahead and also add that component. And then I'll go ahead and also add that component. Okay. And then I'll go ahead and also add that component. So what we're doing here is we will initialize a text box. We will call a gradio.textbox component. Set our scale to 3. We don't want any labels on that. And then we'll add some placeholder text. Here we're saying, okay, enter text and press enter, or speak to your microphone. And then we set the container as false and interactivity to be true. And then also we would also initialize a audio gradio component, which is what the user will use to record their audio, which is this component here. So the source of the audio would be microphone. We would generate a file path, and then we'll also set the scale of this to be 4. So then the last component I will be defining will be the audio playback component. So once the TTS model generates the audio should auto play, right? But we want to add a component that to hear the voice again if the user chooses to. Okay. So this is the generated audio playback component, which is this audio play component. We would have a sentence box, but we wouldn't show that in the UI. We just want to have a sentence box to be able to capture the text that comes from the LLM. Then we'll have the audio playback, which is a gradio audio component. We don't on initialization, there's no value in it. We would have the label to be generated audio response. We want streaming to be true. We want autoplay to be true, which is important because we want the app to just automatically play the audio. We set interactivity to be false, and we also show the label. So we are done defining all the components for this app. And next we would then, so now that we have these components, we need to add functions that, so we need to add the functions that would be triggered once we do an action. Say for example, once the user enters the text, we need to add a function that would run once the user adds the text and pass the text to the LLM, or once the user records in the microphone, we want to add a function that would allow the that would take the audio recorded, transcribe it, and then pass it to the LLM. And then also add a function that would help generate the speech based on the LLM's response. So the first function that we would define would be the add text function. So basically, once the user enters their text in this text box, we would take in the chatbot's history, which is basically just this chatbot, which is the chatbot component, but with the history, with the value and all of its history, like the interaction between the user and the chatbot. And then it would also take in the text that the user just inputted in the text box. And then we would initialize our chatbot history. If we don't have any, if it's empty, we will set our chatbot history to be none, else would retain our chatbot history. And then we would add the text that the user just entered in the text box as the user input, and also set the bot response to none. So the bot response would be updated from the LLM. And then lastly, we would then return this chatbot history, and we would update the text box to be empty. So we kind of make once this function is called, once the user presses enter, this function will be called, and then it would return to whatever called it, the chatbot with its history, and also clear the text box and make it empty. And then this would be sent to another function which would add later on, called generate speech, and then based on this the LLM would make a response, and then based on this the speech will be generated. So we would also add another function which we have defined, called add audio. So similar to the add text, so instead, if the user chooses to use the record microphone button instead, what would happen is we'll also take in like the chatbot history, but in this time we'll take in audio. We'll initialize our chatbot, and then we would pass the audio that the user just recorded into the Whisper model for transcription. And then once we get the response, we would extract the text from the response. And then we would add the transcribed text to the chatbot history like we did in the add text function, and then we just return the chatbot history and also make the text box empty. And then our final help function that we'll be using for today is the generate speech function. So if the user types in their text in the text box and they press enter, this add text function would be triggered. And once this add text function is triggered, the user's text will be added to the chatbot history here, and then we would return the chatbot history, and that chatbot history would be passed to this function called generate speech. So this generate speech is what would now take the chatbot history, and the same thing for the add audio. When the user records their voice, we would transcribe the voice, take the transcribed text, add that to the chatbot history, and then return the chatbot history to the generate speech function. So in the generate speech function, we would pass in the chatbot history, the chatbot voice that we want to use. So in this case, we have either female or male, and then we would, if we are starting up the voice bots initially, we want to have an initial greeting, and then, but subsequently, we want the LLM response to be what we hear. So we'll start by yielding an empty, or so we'll start by yielding an initial empty audio in order to set up the autoplay. So because we want the audio playback component to automatically play, we will need to first set up an empty audio, and then I have this helper function which is in my utils file, which helps us do that. So it would return an empty audio, and no one will hear that, but we kind of need it in order to set up the autoplay function. So once that's done, I also have another helper function inside this function, which will help handle the speech generation and the yielding process. So we would pass the text from either the transcribed text or the imputed text. We would pass the chatbot history and the chatbot voice, and then we would send all of that to a helper function that I've also added in the utils files, which will now help us generate the speech for the sentence. And then once we have our generated speech, we would return the sentence that the user imputed. We return the chatbot history, and would also return the generated speech from the XTTS model. And so if we have an initial greeting, we would call this function to speak, to say our initial, in this case it's, "Hi friend, I'm Amy, an AI coach. How can I help you today?" But if we've kind of subsequently be going on in the conversation, we would just skip that and continuously get and process the sentences from the LLM. So once that is done, we're just going to configure what should happen when each of these components are triggered. So in this case, we'll start from the text box. Once the user submits the text in the text box, we are going to call the add text function, which we just added here, and then we'll pass in as input our chatbot history and then our text box components, and this would return back to us our chatbot history and then also our empty text box. And then once that is done, we're just going to pass the outputs of the add text function into another function, which is this generate speech. And it would take in the chatbot history, would take in the chatbot voice, and then it would output the LLM response, the chatbot history, and the text-to-speech generated audio. And then once that is done, we will then just clear the, once that is done, we would call another function to clear the text box. And then we would do a very similar thing for the record audio component. We would get so the audio record response would be, we would take the audio recording. Once we press stop recording, the button, it would call this function, which is add audio, and we return to us, and it take as input the chatbot and the audio that we just recorded, and it will return to us the outputs. And similarly, it would then pass this outputs to the generate speech function, which would then process the text and the chatbot history and return to us the LLM response and the audio playback. And yeah, that's kind of all of the UI. So I'm just going to go ahead and so yeah, that's all of the UI, and then we just add the last thing, which is to play. So once the application starts, we want to play the initial greeting message from the once I play the initial greeting message, we would pass the generate speech function again, pass our chatbot, which is going to just have, because we initialized the value to be our initial greeting, we pass the voice, and we set our initial greeting to be true, and then it will return to us the same sentence. the chatbot history and the audio playback, and then this audio playback would be played for the user to hear. So let me go ahead and launch our app, our demo. We set debug to be true, we set share to be true. And so we're done, with our app.py file. We've put up all the set up the code to process all the interactions that we get on an app. And then we just go ahead and push all of our changes. We have our app.py file, we have our requirements file, we have our utilities file, we have our examples folder. We're going to just push everything back to our Hugging Face spaces. So let's see what our status is. And then we're just going to add everything. And then we are going to commit our changes. We're just going to say add app files, and then we're going to push, and yay, so we've pushed to the Hugging Face spaces repo. So we'll just go back to that and see our app, and then we'll build it there. And so once we've pushed all our files from our local machine to the Hugging Face spaces, the spaces will then take our file and then deploy it on the GPU machine, the NVIDIA GPU machine that we specified initially, and then deploy the app on that machine. And so we'll just wait for this to build. So feel free to go grab a coffee, a cup of tea. I'm going to drink some water because I'm thirsty. And anyways, I'll see you back once this is done. So our app is done, deployed on Hugging Face spaces, and I'll just refresh.
Hi friend, I'm Amy, an AI coach. How can I help you today?
Hi Amy, can you please tell my lovely friends on YouTube how awesome each and every one of them is?
Of course. Your friends on YouTube are amazing. They definitely deserve some recognition for their hard work and dedication. Keep up the great work.
Yay, thank you.
No problem. Happy to help. Is there anything else I can do to support you?
No, that's all. Thank you so much. I really appreciate you, Amy.
You're welcome. I'm glad I could be of help. Remember, don't hesitate to reach out if you need anything in the future. Stay positive and keep shining.
So anyways, yeah, that's the demo. This was so much fun to build and to share with you. I really do hope you learned something from this. And so basically the goal is just to share how we can build all those like really cool AI apps with open source models. So that's the goal of making these videos. And we would definitely be putting out more AI tutorials, diving deep into the models. So anything you kind of want to see, please put them in the comment section down below. And don't forget to like, share, subscribe. Thank you so much. I love each and every one of you. And I hope to see you all in the next video. Bye.